All right, let's talk about something we've all felt. That moment of frustration when an app is just slow. Today, we're going to dig into how to fix that. We're talking about database optimization, how to take your application from a painful crawl to a full-on sprint.
You know that feeling, right? That little spinning wheel of doom, just going round and round. It tests your patience like nothing else. And you know what? A lot of the time, the real bottleneck isn't your Wi-Fi, it's the database, just struggling to keep up. But the good news is, we can absolutely fix it.
So, what's the fix? Well, the hero of our story is database optimization. It's really just a collection of powerful techniques to make your database, well, better. We're talking about making queries faster, using less CPU and memory, letting more people use the app at once without it breaking a sweat, and just being smarter about how data is stored.
Okay, first things first, let's talk about the foundation. Getting your data structure right from the very beginning is everything. It's like deciding to build a skyscraper on solid rock instead of sand. You prevent so many problems before they even have a chance to start.
So the first big tool in our blueprint is something called indexing. The best way to think about this is to imagine an old-school library card catalog. Instead of walking up and down every single aisle looking for a book, you just go to the catalog, find the right card, and it tells you exactly where to go. A database index does the exact same thing for your data.
And the difference it makes is, well, it's night and day. Without an index, the database has to do what's called a full table scan. It literally reads every single row until it finds what it's looking for. Super slow. But with an index, it becomes a direct lookup. It just jumps straight to the data. We're not talking a little faster. We're talking orders of magnitude faster. Okay, so here's a huge tip, especially if you're interviewing. You should definitely say you'd add indexes to columns you use to filter, join, or sort your data. But, and this is the important part, show that you know the trade-off. Every index you add makes reading data faster, for sure. But it also makes writing data a little bit slower because the database has to update that index too. All right, next up is an idea that sounds super simple, but it makes a massive difference. Just use the right tool for the job. If you pick the smallest, most appropriate data type for a column, you save space. And less space means less data for the database to dig through, which makes everything faster.
I mean, check this out. If you know a number is never going to be more than, say, a few thousand, why use a massive big int? An int is perfect. Or if you're storing someone's name and you know it's going to be under 50 characters, don't use a giant text field. It's all about being precise. It adds up. This brings us to one of the classic debates in the database world: normalization versus denormalization. Normalization is all about being super organized. You get rid of any repeated data to make sure everything is consistent and efficient. On the other hand, denormalization actually duplicates data on purpose because it can help you avoid complex, slow queries, making your app feel way faster.
And here's the thing to remember, especially for an interview. There's no single right answer. It's all about what the app needs. If you're building a banking app, you need absolute data consistency, so you normalize. But if you're building a social media feed that needs to load in a blink, you might denormalize. It's always a strategic choice.
Okay, so we've got a solid blueprint. Now let's talk about how we actually ask the database for information. Seriously, the way you write your query can be the difference between a response that's instant and one that has you tapping your fingers for 5 seconds.
Let's run through 4 quick golden rules. First, and this is a big one, stop using select star. It's like asking a librarian for every book in the building when you just want one. Only ask for the columns you actually need. Second, filter your data as early as possible with the where clause. And finally, get to know your SQL tools. Know when a join is going to be way more efficient than, say, a subquery.
Now this is probably one of the most common performance killers you'll ever see. It's called the N+1 query problem. So the bad way is you grab a list of 10 blog posts, that's one query. Then you loop through them, and for each post you run a new query to get the author's name. That's 1 plus 10, 11 queries. The better way is to grab the posts and then grab all 10 authors' names in one single bulk query. 2 queries instead of 11. Huge difference.
Okay, but what happens when things go really, really well? Your app blows up, you've got millions of users, billions of rows of data. The same old strategies won't cut it. We have to start thinking bigger about architecture.
2 really important words you'll hear are partitioning and sharding. They sound kind of similar, but the difference is key. Partitioning is like taking a giant book and splitting it into smaller chapters. but it's all still one book on one server. Sharding is like splitting that book into totally separate volumes and putting them on different bookshelves, or in this case, different servers. Sharding is how you scale out.
And while we're on architecture, there are two more huge wins. First is caching. This just means you store data that's used all the time, like a user's profile picture, in really fast memory. That way, you don't even have to bother the database for it. And then there's connection pooling. Opening a new connection to the database is slow. So instead, you keep a pool of open connections ready to go. It makes your app feel way more responsive. Okay, last section, and this is crucial. Optimization isn't something you do once and then forget about. It's like car maintenance. You got to do regular health checks to keep things running smoothly and catch any small issues before they become big problems.
A really great habit to get into is batching your operations. Seriously, think of it like going to the grocery store. You wouldn't make 100 separate trips for 100 items, right? You'd make one trip. It's the same here. Instead of sending 100 separate requests to insert 100 rows of data, you send one single request with all of them. It is so much more efficient.
So how do you find the problems in the first place? You need the right tools. Monitoring tools, they're like the check engine light in your car. They tell you something is wrong. Profiling, using a command like explain, is like plugging in the diagnostic computer. It tells you exactly what the database is doing, step by step, so you can see where the slowdown is happening. And that brings us to our last big interview tip. Always, always mention explain. Why? Because it shows you don't just guess at solutions. It proves you use data and diagnostic tools to find the root cause of a problem before you start trying to fix it. That's a huge green flag. So, after all that, what's the big idea? What's the one thing you should walk away with? It's that database optimization is, at its heart, a balancing act. It's all about making smart, strategic decisions and understanding the trade-offs. And this right here, this shows you that core conflict perfectly. You've got read speed, write speed, and storage and consistency. Pretty much everything we talked about today improves one of these, often at the cost of another. Adding an index boosts reads but slows writes. Denormalizing boosts reads but can affect consistency. Knowing which lever to pull and when is the real art form here.
You know, we've just covered 12 really powerful techniques. We've gone from the very foundations like data types and indexing to writing smarter queries and all the way up to big picture architecture and maintenance. You now have a seriously solid toolbox to work with. So I'm going to leave you with a question. Now that you have these tools in your belt, looking at your own projects, what's the one bottleneck you could identify and start tackling tomorrow? Thanks for tuning in.